Hello, welcome to Honeywell Virtual Engineering Technology Experience and our presentation on Collaborative Engineering and Project Execution with Honeywell's Virtual Engineering Platform 4.0. My name is Ronnie Villarreal and I'll be presenting. I have over 30 years of experience in the automation and control industry with Honeywell Process Solutions. Began my career working as an estimator and sales support for 2 years, then joined the project's operations organization as a lead engineer and a consultant working in our strategic corporate accounts program for about 9 years. While in projects and consulting, executed numerous greenfield and brownfield projects, full scope turnkey around the globe. For the past 20 years, I've been working as an engineering leader, primarily working to support the Americas Engineering Organization. Along with those responsibilities, I also lead our global engineering digitization effort. I am based in Houston, Texas, and I have a bachelor's degree in engineering from Texas A&M. This presentation will cover project engineering challenges, digitizing the project delivery cycle, Honeywell's Virtual Engineering Platform 4.0, an introduction into 3 key areas: Design Engineering Questionnaire, DEQ, standardized FDS, drawings and test reports, and technology-assisted testing. Process automation projects have never been easy and seemingly become increasingly more complex with the adoption of new technology and plant operation best practices. Now combine global health concerns, and these challenges are greater than ever. These projects involve enormous amounts of data exchanges in various formats and forms, such as documents, specifications, drawings, and vendor data that are exchanged amongst the various project participants, including engineering procurement contractors, EPCs, main automation contractors, the MAC, third-party vendor, specialty and construction contractors, along with the final end user. Ideal project milestones for these data exchanges are often missed. Our data is incorrect or incomplete, which in turn causes errors or changes in design to occur very late. This results in rework, increased costs, poor quality, and usually delays in the project schedule result in placing the integrated control and safety system on a critical path. Honeywell has begun to solve these current challenges by digitally transforming our project implementation processes across all project phases, front-end engineering design, implementation, and testing. We have a cloud-based environment called Honeywell Virtual Engineering Platform, or HVEP 4.0. This cloud hosts our project data and has our standard builds, checklists, solution packs, and tools seamlessly integrated in to use the same data by all project stakeholders from the start to final deliverable. This significantly improves quality and overall productivity. The Honeywell Virtual Engineering Platform 4.0 digitizes the project engineering processes with a secure, centrally hosted cloud environment. It enables project team members to collaborate on a remote basis using cloud dashboards for transparency view of all the project status and deliverables. The first area you want to look at is called the Design Engineering Questionnaire, which has built into it our proven designs and Honeywell best practices. What we have done is we've digitized our project design checklist and questionnaire, which allows us to capture standardized inputs from multiple sources in a consistent manner. The assembly of these inputs associated and aligned with standard build content then allows for the deliverables, such as the functional design specification, to be generated with the click of a button. I have a short video to demonstrate this. Once we have completed a sufficient portion of the DEQ, we are then able to generate deliverables. Could be in the form of a functional design spec, hardware drawing, or test reports. What we've done is we've taken standard project tools, for example, those used to support drawing generation. They are connected to the project source inputs, which allow auto generation capability of our hardware drawings. I will demonstrate this with a short video. What I'm showing now is a video that will give you a conceptual understanding of the Design Engineering Questionnaire. On the left-hand side of the main menu, you see the inputs, and then the deliverables, and then the testing criteria. This particular questionnaire is used to complete the requirements for a safety system SC cabinet design, where we've tried to maximize these standard options. They're shown in the form of a selection or radio button. In some cases, we also have drop-down menus that allow you to pick. So the concept here is that we would work with the customer to go through and complete all the questions for their particular design. This could be done through a shared team meeting or in a joint collaboration. Once those inputs have been completed, we would save the results. The next step would be to generate the FDS. So we would go to the deliverable and hit the Generate FDS button. The FDS will be formed based on the answers to the questions. What it's doing now is it's aligning the standardized inputs with standardized content. And what we've done is we tried to maximize this to be as relevant to the particular customer as we have. Any place in this document where you see references to figures or drawings, those are pointing directly to the source document. So that helps us maintain alignment with revisions to documents. So what you see here, this is our standard functional design specification for a safety system. The next thing we want to show is how we generate standard hardware drawings. We have, again, another question and answer DEQ type tool called Total Plant Configurator. The customers then would ask us to complete, or we would ask them to provide us the number of inputs, outputs, cabinets, etc. The output of that then is a form of a PRJ file. What we've done here now is we've embedded our standard drawing tool, and we now hit Generate Hardware Drawings, and you see the standard drawing pack. Along with the standard DWG files, we also get a consolidated PDF. We'll open the PDF document, and what you see here is a representation for this particular drawing set, automatically generated based on another DEQ question answer that defined the hardware design aspects for the control system. The next area I want to share is how we've built into the tool engineering dashboards. This particular one here that I'm sharing is a purpose-built engineering dashboard, particularly for us to stay connected with the integrated supply chain on their status of deliverables. This one is used to correlate the hardware factory supply chain to give the project team clear transparency of the cabinets when they are in design phase, build phase, or test phase. All the associated deliverables, like the drawings and bill of materials for each cabinet, are then connected via page links in HVEP to a particular cabinet. In the future, each cabinet will have a QR code, which will allow these drawings then to be connected to them in a remote manner. Okay, the next thing I want to share here with you is a video of the testing. So here you can see the cabinet dashboards. We've selected the cabinet. Once we've selected the cabinet, the application will determine the proper test procedure required for testing that particular cabinet. So we've digitized the paper documents that were being used by the Honeywell factory along with the Honeywell engineering and technician team to go through and test this entire cabinet. So it's all digitized here. It's also available on an iPad or a tablet to be executed locally. The two will become synchronized in the cloud. But here you can see we're going through the test procedures. The test procedures indicate, we would indicate pass, fail in the procedure. If everything passes or nothing, there's no anomalies, then we could have a final document here called the test procedure that would be then allow us to provide you a quality certificate for that particular cabinet that was tested. Next, what I'd like to do is share with you our QuickFAT tool, Technology-Assisted Testing. It is used to assist in verifying and testing the interconnect wiring between the field side terminals in a Marston cabinet or universal remote cabinet and the Experian IOTA. As you know, this can be quite time consuming because it typically requires two people. One person at the terminals to source the signal and another one at the engineering console to confirm receipt. QuickFAT consists of two components. The first component is called the IOMate, a set of electronics that connects directly via a probe set custom configured to align to the terminal manufacturer specifications. Once installed on the rail, it is powered on. They become recognized and available in the IO-Shark application, which resides on the tablet. This association is directly based on the location of the physical placement on the rail. The IO-Shark application that resides in the tablet has a table within it called the IO binding table. This is comprised of a subset of the wiring database and the configuration database. The wiring database portion creates an augmented reality version of the marshalling cabinet, including all the rails, TB headers, and terminals. The application then also uses a portion of the configuration database to choose the appropriate universal I/O personality to source the signals across the wires. Basically, once you've got everything set up, you initiate the test. It's an unmanned test. What you have as an output is a very nice digitized report that is available to be given to the customer to verify you've completed the testing. In summary, using our Honeywell Virtual Engineering Platform's digitized remote collaboration environment, Honeywell, along with EPCs and end-user customers, can all work together to reduce rework and change orders, and avoid placing the integrated control and safety system site installation activities on critical path. More importantly, we can improve quality, drive standardization, and meet on-time project delivery. Feel free to chat with me in the demo center at the Remote Automation Projects booth. Also see our videos, especially the one on QFAT with the IO Mate and IO Shark. Hope to see you there, and thank you for attending.